Welcome to MarineLearn, practical knowledge and training for maritime professionals. Hit the bell button, subscribe, and like the video so we keep bringing valuable content to you.
Welcome, cadets. Today's objective is to standardize the selection and application of the clamping and holding tools utilized in shipboard marine engineering. The foundational law of the workshop is simple. You cannot machine what you cannot secure. This infographic outlines our 4 core operational objectives. First, we'll match specific tools to workpiece geometries. Second, we'll deconstruct these tools to understand mechanical force generation. Third, we'll review load distribution techniques preventing deformation. Finally, we'll execute strict maintenance protocols. This diagram shows the physics of machining. Applying a drill, file, or saw introduces violent rotational, lateral, and compressive forces. Holding tools provide the mandatory equal and opposite anchor. Without this rigid anchor, drill bits bind, measurements drift, and ship components fail. This chart categorizes the shipboard holding arsenal into 3 main functional groups. We begin with the heavy bench work category, which utilizes standard flat-jawed tools for parallel surface contact. This exploded diagram details the engineer's bench vise. The body is cast from rigid iron or steel, featuring a fixed jaw and a moving jaw that travels along a parallel guide. To generate linear clamping force, the operator turns the central spindle, which drives against an internal box nut. Some bench vices feature a quick-release variant. A trigger lever disengages the nut from the threaded spindle, allowing for rapid width adjustments, a vital feature during emergency shipboard repairs. Looking at the diagram on the left, the parallel action of the bench vise jaws yields full surface contact with the workpiece. This makes it a preferred tool for precision filing and sawing. However, cast iron is brittle. If subjected to heavy anvil-style hammering, the vise casting will shatter. In contrast, the leg vise shown here features radial hinged jaws and is constructed from mild steel, which is designed specifically for shock absorption. Your tool selection must match the operational force profile. Use the bench vise for precise cuts, but for a hot forging, switch to the leg vise. Its solid structural leg transfers the massive shock directly to the ship's deck without breaking the tool. Securing hydraulic lines and bilge piping presents a specific geometric challenge. Standard flat jaws apply concentrated pressure that crushes hollow cylinders. Pipe vices solve this problem. Whether using a V-shaped base or a tension chain, they create an even 4-point radial grip. When you need true centering for precise, solid cylindrical shafts, you deploy V-blocks alongside U-clamps. The blocks feature a 90-degree V-angle. When paired with the top-mounted U-clamp, this geometry creates 3 critical points of downward pressure, which prevents lateral rolling. These blocks come in 2 classifications. Grade A blocks are machined from high-quality steel for highly accurate work, while Grade B blocks are cast iron for general machine shop tasks. For intricate assembly, you will rely on portable grips. This pin vise uses a 3-jaw collet chuck to firmly hold microscopic wires and tiny drills. The hinged steel legs of the hand vise are used for securing small rivets and keys.
Beside it, the heavy-duty C-clamp is required for securing layered plate metal directly to bulkheads or drill press tables. This schematic illustrates the proper use of pliers. Flat-nose pliers are engineered strictly for forming sheet metal, while round-nose pliers are meant for wrapping wire and shaping curves. Take note of this strict operational rule. Pliers are exclusively for forming, not holding. Using them to apply high-torque turning force to nuts and bolts will strip the hardware and irreversibly damage the tool's pivot point. Your holding tools pose a direct threat to the materials you are working on. Hardened carbon steel vise jaws will permanently mar and score finished soft metal components. The standard operating procedure is to deploy aluminum soft jaws over the primary jaws. The softer aluminum sacrifices itself to absorb the clamping pressure, protecting the component. Avoid over-torquing. Excessive force will crush the workpiece and permanently bend or strip the vice's internal spindle. Operating these tools effectively requires commanding your own biomechanics through the correct navel stance. To exert flat, controlled force, place your left foot 6 inches forward and left of the vice post. your right foot sits 30 inches back. The workstation itself must be properly aligned. Place your fist under your chin. The top of the vice jaws should align exactly with your elbow. Combine this stance, precise height calibration, and adherence to the zero impact rule, which mandates you never strike a vice handle with a hammer. This ensures you command the tool, rather than the tool injuring you or destroying the part. Tool maintenance is not a suggestion. It is a critical component of your operational readiness at sea. You must eradicate sharp metal swarf using a dedicated bench brush. Clearing metal chips with bare hands is strictly forbidden. Because sea air seizes metal, you must routinely open the jaws fully to wipe and pack the internal square thread and sliding guide with fresh grease. When a vise is idle, it must be returned to its proper resting state. The jaws must be left lightly touching, but never tightened down. Furthermore, the handle must be dropped into a perfectly vertical position. This eliminates a dangerous snagging hazard as personnel move through cramped spaces in heavy seas. We will now initiate a brief operational readiness assessment to review these concepts. Aluminum is specifically chosen for soft jaws because it sacrifices itself to absorb load and prevent scoring. And if you are preparing to heavily hammer a red-hot forging, you must use a mild steel leg vise, which transfers the force directly to the floor. The superior tool for holding a 40mm cylindrical shaft for precise drilling is a V-block with a U-clamp, providing 3 stable points of contact. Finally, an idle bench vise handle must be left vertical to prevent personnel from snagging it. Precision is not an accident. The quality of your final cut is dictated by the quality of your initial clamp. A strictly secured workpiece is the foundation of safe and accurate marine engineering. Respect the tool, and it will anchor your work in the harshest environments.